Hello, this is Scholar Strat doing some math today in algebra. We're going to represent functions as graphs. So we have an ordered pair, and these are two numbers in parentheses, usually x comma y. The first number represents the x coordinate, and the second number is the y coordinate. So if we had 2 comma 3, that would mean x equals 2, y equals 3. So here we go. Graph the function y equals x plus 1 with domain 1, 2, 3, 4, 5. So they're telling us our x values is 1, 2, 3, 4, 5. We plug each of those into the equation. So 1 plus 1. So remember y equals x plus 1. So I'm going to make 1 plus 1, that equals 2. 2 plus 1, that equals 3. And so on, calculating each of these. 2, 3, 4, 5, 6. Just adding 1. Okay, and now we're going to make ordered pairs. So 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 comma 5, and 5 comma 6. Okay, so when we have a graph, hopefully you've seen this before, but we have an x-axis, and a y-axis. So the x-axis represents this horizontal line, and then the y-axis is our vertical line. And when we're graphing this, we are, so for example, let's graph 1, 2. So in the x direction, so we're going to start at 0, and so our x is 1, and our y is 2. So I'm going to go 1 to the right, and then up 2. That is the coordinate 1 comma 2. The coordinate 2 comma 3 goes here. Then 3 comma 4 goes here. Then 4 comma 5. And 5 comma 6. Okay. So when we're doing these, let's do another one. Okay. So graph the function y equals 1/3 x plus 1 with domain 0, 3, 6, 9, and 12. So let's make a table. Okay, x, y. So there, our domain is 0. So we're plugging 0 in the equation, 3 in the equation, 6 in the equation, 9 in the equation, and 12 into the equation. Okay, so let's do that. So I'm plugging in 0, so y equals 1/3 of 0 plus 1. So y equals 1, so that's 1 there. And then let's plug in 2. So y equals 1/3 of 2, or not 2, sorry. Our domain is 3, right? Plugging in 3 in the equation, plus 1. So 1/3 of 3 is 1. So 1 plus 1 equals 2. If I plug in 6, 1/3 of 6 plus 1. 1/3 of 6 is 2. Plus 1 equals 3. 1/3 of of 9 plus 1 is 3 plus 1, which is 4. And then if we plug in 12, 1/3 of 12 is 4. And then plus 1 is 5. And now we're going to graph it. Okay? So I'm looking, here, let's use a color here to make sure we all are understanding here. So I have 0, 1 right here. So I start at, so my x, I go to 0, which is right here, and then I go to up 1 for my y. Okay, and then I go to 3, and go up to 2. 6 gives me 3. 9 gives me 4. And 12 gives me 5. So each of those dots there represents the coordinates there. We have 0, 1, 3, 2, 6, 3, 9, 4, and 5, or 12, 5. All right, write a function rule for the function represented by the graph. Identify the domain and range of the function. So my domain are my x values. Okay. So this dot here is at 2, 0. It's on the y-axis, so it didn't go up any. Or it's on the x-axis, so it didn't go up any. And then it went 2 in the x direction. So the next one here is 4, 1, 6, 6, 2, yep. And then 8, 3. And 10, 4. So find a pattern. So what's going on here? So at 2, we go down to 0, 4 we go to 1, 6 we go to 2, 8 we go to 3, 10 we go to 4. So what's going on here? So our pattern, if you don't see it, is actually, so the difference here is 1, right? Plus 1, plus 1, plus 1. But that doesn't help us. But here's our pattern. What's going on is the output is 1 less than half the input. And what I'm saying is y equals 1/2 x minus 1. So if I take half and subtract 1, we'll get the output. So if I plugged 2 in, so I have 1/2 of 2 minus 1, I'll get 1 minus 1, which is 0. If I plugged in 1/2 of 4 minus 1, we'll get 2 minus 1, which is 1. And so on and so forth. So this works. Okay, write a rule for the function represented by the graph. Identify domain and range. Okay. So let's start off with our domain and range. D for domain, R for range. So our domain is 1, 2, 3, 4. And then our y values are 0, 3. Oh, there's actually space. Well, let's put those down here. 1, 2, 3, 4. And our range is 0, 3, 6, and 9. Okay, what is my rule? So if I plug in 1, I get 0. If I plug in 2, I get 3. So it looks like it's just going up by 3, 6, 9. But it's not exactly 3x, because if I plug in 1, I get 0. But if I put in minus 3, that would work. Y equals 3x minus 3. Because if I plug in 1, 3 times 1 is 3, minus 3 is 0. If I plug in 2, 3 times 2 is 6, minus 3 is 3. Okay. Always make a table, because it might help you see the patterns. So x, y, 1, 2, 3, 4, 0, 3, 6, 9. Alright, part B. Let's try this. X, Y. So our domain here, we have 2, 4, 6, 8. Okay, and then our range, our y values are 6, 7, 8, 9. So this is going up by 1. The y values are. So here we go, 2, 4, 6, 8 for our domain, 6, 7, 8, 9. Okay. So if I plug in 2, I get 6. So I have y equals something. So if I plug in 2 for x, how do I get 6? Well, if I had 2, I add 4. But does that work if I plug in 4? 4 plus 4 is 8. So that doesn't work. It's okay if you don't see the pattern, but this is actually how it works. Later on, we'll teach you how to make these rules. But for now, you're just going to look at examples, and maybe you can guess the pattern yourselves. Alright, I believe that is it for today. Have a good one.